Hello and welcome to another Mattia Calculus tutorial. Today we'll be talking about the interval of convergence. So if you remember back, the ratio test is what determines whether or not an infinite series either diverges or if it converges. And to use the ratio test, we would have L equals to the limit of n goes to infinity of the absolute value of a of n plus 1 over a of n. And the idea is if the next term, a of n plus 1, is less than a of n, or a of n, then the absolute value of this would then be less than 1. And therefore, as the terms get progressively smaller and the number of terms go on to infinity, then the series would eventually converge. So if L is less than 1, it would converge. So conversely, if L is greater than 1, the series diverges. If L is equal to 1, the ratio test is inconclusive and we're not sure whether or not it converges or diverges. So this ratio test can easily be used to find whether or not a series such as this one either converges or diverges, and in this case it would diverge. But then the question for, let's just say, the summation from n equals 1 to infinity of 2 to the n over n of times 4x minus 8 over n. It's a different story, mainly because this summation has x. And so the question is not whether or not this converges, but at what values of x does it converge? And that set of values of x is called the interval of convergence. So to solve this, we still use the ratio test. L would equal the limit of n goes to infinity of the absolute value of 2 of n plus 1 over n plus 1 times 4x minus 8 to the n plus 1. And this would be all over a sub n, which is just the general term. So with some rearranging, dividing would just be multiplying by the reciprocal. So I'm just going to solve this. That would be the first step. So it would become 2 to the n plus 1 times 4x minus 8 to the n plus 1 over n plus 1, and this would be multiplied by the reciprocal of this part right here, which is n over 2 to the n times 4x minus 8 to the n. Okay, so from here, how would we simplify it further? We can notice that 2 to the n can be divided to 1 in this entire thing. Because over here in the numerator, 2 to the n plus 1 is really just 2 to the n times 2 to the first, if you remember your exponent rules. And 2 to the n over 2 to the n, that divides to 1. Similarly, with this part right here, 4x minus 8 to the n plus 1 is the same thing as 4x minus 8 to the n times 4x minus 8 to the first. And so the part 4x minus 8 to the n would divide to 1 with the denominator part right here, 4x minus 8 to the n. And once you simplify that down, you would end up getting, let's see, limit of n goes to infinity of the absolute value of 2n times 4x minus 8 all over n plus 1. From there, we can look at this part right here with 4x minus 8. As n goes to infinity, this part right here really doesn't change. As n changes, there's no n here. So what we can do is we can take this binomial and we can move it outside of the limit. So if we rearrange it, then it would then be the absolute value of 4x minus 8 times the limit of n goes to infinity. We no longer need the absolute value for inside the limit because it's just n and that's never going to be negative. So it'd be the limit of n goes to infinity of 2n over n plus 1. Okay, so here we can see that limit of n goes to infinity of 2n over n plus 1. This, as n goes to infinity, considering the numerator and the denominator have the same degree, it would just simply go to the leading coefficient, or in this case, 2 over 1. So 2 over 1, 2. We would be left with L would equal the absolute value of 4x minus 8 times 2. And the next part of the ratio test says that if L is less than 1, then the series converges. So when this part is essentially minus 8 times 2, when this part is less than 1, the series would converge. Now, here you would just simply solve the inequality. You would solve for what interval of x is this true. And here I'll just solve it. 4x minus 8. We would divide both sides by 2. From there, you would say it's 4x minus 8 must be less than 1/2 but greater than negative 1/2. And then add 8 to both sides and divide by 4. You would get 15 over 8 is less than x, which is less than 17 over 8. Now, here we're only halfway done with the interval of convergence, because from here we need to test the endpoints, because the values, if x equals 17 over 8 or 15 over 8, if you remember back when I talked about ratio tests, it would equal, L would equal 1, and therefore it'd be inconclusive. So what we do here is checking the endpoints. Alright, so I'll just leave that at the top. If x was equal to 15 over 8, then it would become the summation of n equals 1 to infinity of 2 to the n over n times 15 over 2 minus 8. This is negative 1/2 to the n. And simplifying this, you would have the summation of n equals 1 to infinity of negative 1 to the n over n. And if you recognize, this is an alternating harmonic series, so it converges. And therefore, we've tested that if x was equal to 15 over 8, we know it converges. So x can be greater than or equal to 15 over 8. Next, we check the other endpoint of 17 over 8. If x equals 17 over 8, then it would be the summation. If you were to use the same process, you would end up getting 1 over n after your simplification. And this does not converge, it diverges, and therefore you wouldn't include this endpoint right here. So finally, your interval of convergence would be x would be greater than or equal to 15 over 8, and it will be less than 17 over 8. Thank you for watching.